Hi students, today we are going to start a new chapter, force and pressure. In class 7, you have learned how objects move. Do you recall how we can decide whether an object is moving faster than the other? What does the distance moved by an object in unit time indicate? You also know that a moving object like a ball rolling on the ground slows down. Sometimes it may change its direction of motion. It is also possible that the ball may slow down and also changes its direction. Have you ever wondered what makes an object slow down or go faster? Or change its direction of motion? Let us recall some of our everyday experiences. What do you do to make a football move? What do you do to make a moving ball move faster? How does a goalkeeper stop a ball? A hockey player changes the direction of the moving ball with a flick of the stick. How do fielders stop a ball hit by a batsman? In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown, or flicked. What is a force? What can it do bodies on which it is applied? We shall seek answers to such questions in the chapter. Force. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change in the state of motion of an object, not the point. Each of these actions usually result in some kind of changes in the state of motion of an object. Okay. A force is a push or pull or both. Not the point. A force is a push or pull or both. A force cannot be seen, but we can feel and observe the effects of force. Okay? Push. A force to move an object away from our bodies. What is push? A force to move an object away from our bodies. What is pull? A pull is when we apply a force to move an object towards our body. Note the point. A pull is when we apply a force to move an object towards our body. So look at the figure. A man pulling the drawer of the table and a man pushing the drawer of the table. Both are happens. Okay, man pulling the drawer of the table. Okay, clear? So, not the point. A force cannot be seen, what we can feel and observe the effect of force. Okay, so we are moving to the next slide. The definition of force. Now that a force is the push or pull on an object. Okay, example, if an object has to be moved, it has to be pushed or pulled. These are some examples of force. Look at the first figure. A, a man applies a force to move the car at rest. The first picture shows a man applies a force. Force means that there is push to move the car at rest. The figure 2 and 4 shows animals pulling the carts. These are also examples of force. Okay. The third figure. The third figure shows a hockey player hit the ball. So these are all examples of force. So move on to the next slide. Listen here. A force. Force is a push or pull or both. We have studied earlier. A force cannot be seen, but we can feel and observe the effects of the force. So it can be classified into two. Means push. Push means an object, a force to move an object away from our bodies. Not the point. A force to move an object away from our bodies. So what is pull? A pull is when we apply a force to move an object towards our body. Okay, the two examples, that is example of push. Okay, pressing the pedal of the cycle, that is an example of push. Pressing the pedal of the cycle. These are the examples in everyday life. Okay, so example of pull, pulling the drawer of the table. Okay, I hope it is clear. It's what is force? That is, force is a push or pull or both. A force cannot be seen, but we can feel and observe the effects of the force. So two examples of force, two classification, that is push and pull. The push, a force to move an object away from our bodies. And second one, pull. A pull is when we apply a force to move an object towards our body. So examples. Example of push, pressing the pedal of cycle. Example of pull, pulling the drawer of the table. Okay, I hope it is clear. So we are moving on to the next slide. So force. First one, force to move a stationary body. It is clear. It is clear. Force to move a stationary body. So force can also change the speed of a moving body. We know that. Force can also change the speed of the moving body. Okay. So force can change the shape of a moving body. Force can change the shape of a moving body. Then the force can change the direction of moving body. We know that. Force can change the direction of the moving body. And force can stopping a moving. Okay, note the points, the characteristics of force. So force can move a stationary body. It is clear. And force can change the speed of a moving body, and force can change the shape of a moving body, and force can change the direction of moving body, and force can change or stop a moving body. I hope it is clear. So move on to the next slide. So effects of force on an object. So as we discussed earlier, So can we take points? Okay, the first point, force can make an object to move from rest. The same points we studied earlier. Second one, the force can stop a moving object. And third one, force can change the speed of an object if it is moving. And fourth one, force can change the direction of a motion of an object. The fifth one is force can change the shape of an object. And force may cause one or more of these effects. Okay. Okay. In these pictures, it is shown how various activities are performed with the help of force. Okay. Example, the moving an object from rest is shown in the last picture. Where man applies a force to move the car at rest. Okay, sorry, it's the first picture. I am sorry, it's the first picture. A man moving an object from rest is shown in the first picture. Okay, so man applies a force to move the car at rest. Okay, I'm sorry. Then the second figure, a goalkeeper using force to stop the football. A goalkeeper using the force to stop the football. It is an application, effects of force. Okay, the third one, a cyclist using force to change the direction. A cyclist using force to change the direction. The fourth figure, the cricketer hitting a ball in a particular direction requires force. Okay, the cricketers also use force because the cricketers hitting a ball in a particular direction requires force. So the last figure, okay, making of tortilla shows how force causes change in shape. Note the point. How a force can change the shape. Okay, so making of the last picture, the making of tortilla shows how force causes the change in shape. Making of means chapati making. Okay, chapati making. Okay, we are moving on to the next slide. Okay, listen to the figure. A body is at rest. Okay, listen that. If two forces act on a body in the same direction, the net force is the sum of these two forces. The net force is the sum of these forces. Okay, we apply a force of 5 Newton and 10 Newton in same direction. For example, we apply a force of 5 Newton and 10 Newton in the same direction. That is a net force equal to 10 plus 5, that is 50 Newton. Okay, I hope it is clear. I repeat, if we apply a force of 10 Newton and 5 Newton to a body is at rest, so the net force acting on the body is equal to 10 plus 5, that is 50 Newton. So look at the figure, a body is at rest. Okay, we apply a force of F1 and F2 in the same direction. Note the point. We apply a force of F1 and F2 in the same direction. So the net force is equal to F1 plus F2. Okay, the body will move on the direction of force because F1 and F2 is in the same direction. I hope it is clear. So we are moving to the next case. If two forces act on a body in opposite directions, the net force is the difference between the two forces. Note the point. If two forces act on a body in opposite directions, the net force is the difference between the two forces. The net force is the difference between the two forces. For example, a body is at rest. We apply a force of 10 Newton. For example, we apply a force of we apply a force of 10 Newton in one direction, and we apply another force of 6 Newton. Another force of 6 Newton in the opposite direction. So what is the difference in forces? 10 minus 6, that is equal to 4 Newton. So body will move the direction of 10 Newton force. The body will move the direction of 10 Newton force. Okay, I repeat. If a force of 10 Newton is applied in one direction, for example, F1 is taken as 10 Newton. For example, F1 is taken as 10 Newton and F2 is taken as 6 Newton. We know that F1 is applied rightwards and F2 is applied left. Okay, so F1 is applied in one direction and F2 is applied in opposite direction. So we know that 10 Newton is greater. That is difference in force, that is equal to 10 minus 6, which is equal to 4 Newton. So the difference in force is 4 Newton. So body will move in the direction of F1 because F1 is 10 Newton. I hope it is clear. Okay. So the next topic, well, very simple topics. Okay, there are types of forces. There we know that so many type of forces are here. So the first type, there are two main types of forces. They are contact forces and non-contact forces. There are two main types of forces. There are contact forces and non-contact forces. Okay, what is contact force? A contact force is a force exerted by one object on another when they are in contact with each other. Very simple explanation. Okay, when there are contact forces are exerted by one object on another when they are in contact with each other. So contact forces of two types. One is muscular force. We will discuss in the next slide, and force of friction. Okay, so these two forces are contact forces because when these forces happens, forces are exerted by one object on another when they are in contact with each other. Underline the statement, when they are in contact with each other. Are you okay with it? Okay, then non-contact forces. So what is non-contact forces? Non-contact forces means yes, the forces exerted by one object on another without any contact with each other. The forces exerted by one object on another without any contact with each other. Okay, the forces exerted by one object on another without any contact with each other. So non-contacted forces are of three types. They are, first one, the magnetic force, second one, the electrostatic force, and third one, the gravitational force. Three examples: magnetic force, we will explain the next slide, and electrostatic force and the gravitational force. So I repeat, there are two types of forces. There are mainly two types of forces. The first one is contact force. The second one is non-contact force. Okay, contact force, it is a forces exerted by one object on another object. The forces exerted by one object on another object when they are in contact with each other. So what is non-contact forces? It is also the force exerted by one object on another without any contact with each other. If they are in contact, contact force. If they are not contact, non-contact force. That's all. Okay, without any contact means non-contact force. With the contact means contact force. That's all. Okay, contact forces examples, that is muscular force, we'll discuss it in the next slide. Then force of friction, we know that. Okay, non-contact force, magnetic force, electrostatic force, and a gravitational force. Okay, I hope it is clear. So move on. So we are moving on to the next topic. Contact forces is muscular forces. Okay, listen here. Can you push or lift a book lying on a table without touching it? Can you lift a bucket of water without holding? Generally, to apply a force on an object, your body has to be in contact with the object. Okay. Are you okay with it? Generally, to apply a force on an object, your body has to be in contact with the object. The contact may also be with the help of a stick or piece of rope. Not the point. The contact may also be with the help of a stick or a piece of rope. When we push an object like a school bag or lift a bucket of water, where does the force come from? This force is caused by the action of muscles in our body. Okay. Are you okay? Note the point. This force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as muscular forces. Note the point. The force resulting due to the action of muscles is known as muscular forces. Okay. So look at the slide. Muscular force is the force exerted by the muscles of our body. We use muscular force for our various activities. Okay. Animals also make use of muscular force to carry out their physical activities and other tasks. We know that. We know that earlier. Animals like bullocks, horses, donkeys, camels are used to perform various tasks for us. Okay, clear? So, the muscular force is the force exerted by the muscles of our body. Note the point. I repeat, muscular force is the force exerted by the muscles of our body. Okay. So, the first picture shows a man cycling. Here in the force is exerted by man. Okay. The second and fourth figure shows animals pulling the carts. Okay. I hope it is clear. The second and fourth figure shows animals pulling the carts. The third is an athlete who is using her muscular force to overcome the hurdle. Note the point. An athlete who is athlete who's using her muscular force to overcome the hurdle. I hope it is clear. So move on to the next slide, that is force of friction. So, one of the beautiful and super beautiful portions in this force, chapter force. Okay, force of friction. Recall some of your experiences. Okay, my students, recall some of your experiences. A ball rolling along the ground gradually slows down and finally comes to rest. We know that. Clearly know that a ball rolling along the ground gradually slows down and finally comes to rest. When we stop pedaling a bicycle, it gradually slows down and finally comes to stop. Okay. A car or a scooter also comes to rest. Okay. Once its engine is switched off, a car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing. A boat comes to rest if we stop rowing. Can you add some such experience? In all these situations, no force appear to be acting on the objects. As their speed is gradually decreases, they come to rest after some time. Okay, you know that. What causes a change in their state of motion? Could some force be acting on them? The force responsible for the changing the state of motion of objects in all these examples is the force of friction. Okay. So the look at the diagram. Look at the slide. A force of friction is the force which is opposes the motion of an object over a surface. Example, a ball rolling ground. We have discussed earlier. A ball rolling on ground gradually slows down and comes to rest due to force of friction. If we stop pedaling a bicycle, it gradually slows down and comes to rest due to force of friction. Okay. Thank you.